So first body 1. So down at joint A, the pin is part of member 1. So the connection to the ground and the connection to body 2 both apply to body 1. So I'll write this as force on 1 by 2 and RA. None of these have masses, I don't think. And then up here, there's the force on 1 by 3. And then there is the cable force parallel to the cable away from the body. So I'll call that T.
That's 3,000 newtons, right?
Oh, yeah, that's right. That's 3,000 newtons.
So the F1 into an N, RA, is that like the fixed joint?
There's no fixed joint. The RA is, so if we draw it from, let's think of it from the side. So there is body 1. And then there is the connection to the ground. And then there is body 2. And a pin connects them. So this is body 1, ground, body 2. And the red shaded stuff is what we're considering to be body 1. And so that's a pin joint connection with the ground to body 1 and a pin joint connection to body 2. And for my about point, I'll choose this down here. Let's see, how tall is this thing? Oh, it gives, it actually gives coordinates for all of these. So, well, A, just by chance, but I guess not by chance because I'm the one who made this problem and I'm the one who chose that about point. So that's just the way I see these problems. But what I chose as the about point is given as the origin of the problem. So I'm just going to, so that means that the coordinates of those points are also the row vectors. Okay. Anytime your origin is the about point, then the coordinates of the different points are the row vectors. So I'll start with F12, row vector is 0, force vector is F12x, F12y, cross product is 0. Then RA, row vector is 0. Force vector is RAX, RAY. Cross product is 0. Then the 3,000, that is the point B. So the row vector is 0, 0.6. And the force is 3,000, 0. And the cross product is
negative 1,800.
Yeah. And then F13, that is at C, which is 0.3, 0.7. And the force vector is F13x, F13y, and the cross product is 0.3 F13y minus 0.7 F13x. And so the equations, we have F12x plus RAX plus F13x is equal to negative 3,000. And the second one, F12y plus RAY plus F13y is equal to 0. And then the third equation says negative 0.7 F13x plus 0.3 F13y is equal to positive 1,800. How many equations are we going to have for this problem? Yeah, I mean, I guess it sort of depends whether you treat the pulley as a separate body. I guess I'm going to treat the pulley as part of member 2. So yeah, but 3 equations for each body that you isolate, so 9 total equations. And then body 2. Well, look at this side view of A. Is body 2 touching the ground? No, it's only touching body 1. So down here, all we have is the force, negative force on 1 by 2. That's the force on 2 by 1. And, oh, I said I was going to include the pulley up here. Let me do that. So I'm going to treat this all like a single body. So that pulley is part of member 2. So member 2 has a force on 2 by 3. And it also has these cable forces, one parallel to the cable away from the body this way, and one this way.
Could we include them with one vector, just moving the row vector like point, what was the radius, 0.1 in each direction?
Can you treat those like they act at the same point? I think I would say just be careful on that if it doesn't pop into your head immediately why you can do it that way. Just don't take any shortcuts unless it's obvious why you can take those shortcuts. It's not obvious to me, at least, why looking at it you could do that. So I'm just gonna do the full thing, So D, we can see that the radius of that pulley is 0.1 from looking at the coordinates. So okay, for the joint A, we have negative F12. The row vector is 0. You can move the about point for each body, but I'm going to just keep it the same since we already have those coordinates. So negative F12x, negative F12y, cross product is 0. Then the F23, that acts at D, which is 0.6, 0.5. The force vector is F23x, F23y, 0.6 F23y minus 0.5 F23x. Then the 3,000 going this way, that acts at 0.6, 0.6. And the force vector is negative 3,000, 0.
So when we were doing the free body dam for the body one,
Uh-huh.
that 2,000 force was pointing the other way.
Yes. So any cable force, the rule is whatever body you isolate, it acts parallel to the cable, away from the body you're isolating.
Okay.
So if you ever get confused, just remind yourself about that rule, And so this gives positive 1,800.
And since we'll make cross-body multiplication, the x distance for the cable doesn't really matter. It could be
Correct.
7, it could be
Yep.
several times the distance.
Right.
But wouldn't factor in.
Correct. Yep. And then the 3,000 down. So that one is acting at 0.7, 0.5. And the force is 0, negative 3,000. And so that is negative 2,100. Okay, so equation 4 says negative F12x plus F23x is equal to positive 3,000. Equation 5 says negative F12y plus F23y is equal to positive 3,000. And equation 6 says negative 0.5 F23x plus 0.6 F23y is equal to positive 300. And then free body diagram for body 3. So that's this body. Up here we have negative force on 1/3. In the middle, we have negative force on 2/3. And what about those two cable forces?
No.
They don't act on body 3 because I made that pulley part of body 2. Okay. You also could do this as with a fourth body, and you get 12 equations for 12 variables, and in the end, you'd get the same answers. And then the last one is yeah. RE. That's perpendicular to the incline. So we're going to have to calculate, figure out what that is. Hopefully it says somewhere. Yeah, angle of 20 degrees with the horizontal. Okay, so row vector, force vector, moment vector. So for negative F13, this is the first one where that choice of about point I'm using seems pretty odd. I'm going to keep using an about point for this body that's like over here.
Oh,
But-
can we do that?
What?
Set our point outside the body?
Yeah, you can totally do that.
Oh,
You can put it anywhere. Usually it just makes the calculations messier, so there's no point. But in this case, since we have all the coordinates given, I'm going to just keep doing it. So yeah, my about point is over there. F13, so that is at the point C, so point 3.7. Force is negative F13x, negative F13y. Cross product is negative 0.3 F13y plus 0.7 F13x. Then that negative F23, that's acting at D, 0.6.5. The force is negative F23x, negative F23y. Cross product is negative 0.6 F23y plus 0.5 F23x. And then last is that force RE. That is acting at the location 1, 0. And we're told that that makes an angle of 20 degrees, that incline, with the horizontal. Okay, so if this is our coordinate system,
Half B is at an angle of 160.
it would be, so I'm gonna go make one vector that's along the incline like this, and we're given that this angle is 20 degrees. And then we want something perpendicular to that. So I'm going to draw a vector that's 90 degrees this way. And so my angle is negative 20 plus 90,
70.
so 70. And so this is RE times cosine and sine of 70, which is 0.342 RE, 0.940 RE. And the cross product is 0.940 RE. And so equation 7 says negative F13x minus F23x plus 0.342 RE is equal to 0. Equation 8 says negative F13y minus F23y plus 0.940 RE is equal to 0. And then equation 9 says 0.7 F13X minus 0.3 F13Y plus 0.5 F23X minus 0.6 F23Y plus 0.940 RE is equal to 0. And that's our 9 equations for 9 variables. Any questions about that one? And now,
So what is it looking for when it asks for the internal loads for refrigerator?
oh man, that should not be there. We haven't talked about that yet. That's just me moving a question from one topic to another one and not changing the text. Mhm.
Thanks.
Sure. Okay, so now the rangeur. If you ever see the movie Beauty and the Beast again, you probably haven't watched that for a few years, but you can change one of the songs to rangeur if you ever want. So just keep that in mind. Maybe when you have kids. They're popping up to say rangeur, rangeur. Okay. We have to figure out all these dimensions. So I'm going to call this like my origin, and I'm going to call this A, B, C, D, E. So from the origin, this point A is 0.1, and then the height doesn't matter. I don't know, I'll call that H, but that's not going to come into anything. B is 0.1, negative H. C is negative 0.01, positive 0.01. D,
Was it a positive 0.02 or is
that's between the 2 points there. And then negative 0.01, negative 0.01. And then E is negative 0.060. And then I guess those two R points, I guess I'll call that F and G.
Can you put them in meters?
What?
You should change them to meters.
That's what I did, yeah.
But wouldn't it would still just, multiply, it would still come out the same answer if you kept them in centimeter units versus meters, right?
Yeah, that's right. So negative 0.07, and then I'll call that H2, which also won't matter. And then G is negative 0.07, negative H2. And then I'll just keep using the origin as the about point. So, and let me name these bodies. So I'll call this body 1, body 2, body 3, 4, and that's it. Okay, so 1. There's a force of 50. And here there is a force on 1/2. And here there is a force on 1/3. So first I'll do F12. That's the one acting at the origin. So the row vector is 0. The force is F12x, F12y. Cross product is 0. Then F13. F13. So that's acting at C, which is negative 0.01, positive 0.01. And the force is F13x, F13y. Cross product is negative 0.01 F13y minus 0.01 F13x. And then last is the 50. That is acting at the point A, so 0.1 H.
I think for these one in the answer, you had an RB2, I think the same as the F.
Yeah, I think if I remember right, I did this sort of like, I kind of went off script in my solution to this. I used the fact that there's symmetry here, and I thought of this as like, I think this is what I did. I think, so I imagined this being locked to like a wall or something. And then I imagined that this piece, all it does is slide back and forth this way. So I made that a pin and slot joint. And then I just did the calculation for half of this thing. Okay, which gives you the same answers. But the way I'm going to do it here is just following all the steps, not doing any extra thinking, and it works out the same way. It's just instead of doing it as 2 bodies, you do it as 4 bodies. So the force is 0, negative 50. And here's where you can see that that H doesn't come into anything. The cross product there is negative 5. And let's just, I'm going to skip writing down the equations, but that's 3 equations. And then we'll go to body 2. There's the 50 Newton force. Here, there's negative force on 1/2. And then here is the force on 2/4. So I'll start out with negative F12. Rho vector is 0. Force is negative F12x, negative F12y. Cross product is 0. Then positive F24. That is at the point D, which is negative 0.01, negative 0.01. The force is F24x, F24y. Cross product is negative 0.01 F24y plus 0.01 F24x. And then last is the 50. So that acts at B, 0.1 negative H. The force is 0.50. And again, that H disappears from our equations. This is just positive 5. And then free body diagram of 3. Okay, so that goes sort of like this. Here there is a negative force on 1/3. Then at E there is F34. And then here there is R. Okay, so negative F13, that happens at the point C. So negative 0.01, positive 0.01. The force is negative F13x, negative F13y. Cross product is positive 0.01 F13y plus 0.01 F13x. Next is F34. That happens at E, which is negative 0.060. The force is F34x, F34y. cross product is negative 0.06 F34Y. And then last is R.
What is your about point that was perfectly?
My about point is still like,
at the
um,
origin?
it's still the same place as it was for all of these bodies at the origin, exactly.
But for bodies 3 and 4, like, they're not touching the origin.
Yeah, that's fine.
Okay.
Yeah, you can, so for any statics problem, there's nothing special about being on the body. Okay, and so this is F negative 0.07 H2. And the force is 0 R. So the moment is negative 0.07 R. And then the last one, we have the force on 4/2, which is negative F24. And here we have negative F34. And then here we have R. And I'm going to skip this, but same approach. Okay, so how many variables do we have? We know we have 12 equations. So let's count these.
You have 9 variables on this.
Okay, so let's see. We have 1, 2, 3, 4, 5, 6, 7, 8, and then R is 9. That's what I get, yeah. So that means that probably we could have done this, you could solve this body by not doing the last free body diagram and stuff. But all you're doing is looking for a system of 9 equations where none are linear multiples of others, you know. Usually that just means you can just omit one of your bodies or however many equations you need, and it'll give you the answers. The reason that happens in this case is because of all the symmetry. Any questions about that one? Okay.